the biggest difference is that when we do a get on an order or an account, why am I saying order? Because that's what I do in my daily life. I handle orders. And for some reason, I decided let's use accounts. Because let's confuse myself. So when we read an order, we can't just read it from the database and view it. We have to calculate the current state. And we do that with something that I call an account view here, which basically collects all the events from the database and create an account from them. And the from event thing here is just a for loop over all the events and doing some business logic on each event. And here you can see that since I have very easy business logic, all I have to do is either increase or decrease the current balance. But this works great even if you have many different types of events, and you can do it much prettier than this if there's a reason for it and it's not just 6 lines. But a good thing is that I can also see everything that happened. I can get a log of what happened to this order by just doing a list of the events instead. And that's really nice, because people usually come up with things later that they wanted you to do, but they didn't think about. We can look on more on that later. So now when you know some about it, you think, but my database have transactions. And I really like them, because when you withdraw an amount from an account, you don't want to make it possible to do that twice at the same time. So you can use like update if, for example, in Postgres and stuff, and make sure that you don't go below 0 on your amount. Here we can't have any logic in our database. So how do we solve that? And if you could see something here, I would tell you why, but you can't. So you just have to trust me instead. It's easy to trust someone from Sweden. We're really nice people. Yeah. No, actually we are. So what we do is, when we create something, we number them. So the first thing that usually happens to an account is that you create it. So that will be version 1 of this account. And then when we update it, that update is version 2. And we are most likely storing this somewhere. So if we, for example, are using a relational database, we can have a unique index on the version and the account ID. And that makes sure that we can't insert the same thing twice. And we'll have some logic to verify that. So here we can see my database is a hash map. It's really fast. But it's kind of bad at handling things like this, though, so I had to do some ugly if statement, but it's just, it's not production ready. That's the next version. And also I have my cursor in the way, so you can't actually see. So here we see that, okay, so if there was more events than I thought, then we can throw a concurrent modification exception. That sounds cool. Yeah, you see, CQRS, it's cool. It's important. And a good thing with this exception is that we can retry. So in our business logic, we can keep retrying until it works, because on each retry, we can start from the beginning and, okay, so there is a new event, let's fetch that as well, replay the business logic, and see what happens now. And if it works, it works. If it doesn't, we'll return that error instead to the customer or user, as they are called. And that's cool. And this bird is pretty as well. That's also important. More pretty birds. So we discovered when doing this that you have to experience new things. And we claim that we like that, but really we're developers. We don't want things to change too much unless we start that change. So we were really good at testing. We had many different services in production, and we had unit tests, like 90% coverage or whatever, and we did black box testing and integration testing and everything. And then once we were live with this event sourcing, we released a new version in continuous delivery as we do, because we're cool. And every single request failed. That makes you sad. It's like, I have 90% coverage. How on earth can every call fail? And it turns out we added a field to an event. And in our tests, that field is there. In our integration tests, when we create something new, it's there. In production, where we have a year of data, it's not there. So that's kind of annoying. And not something that we're used to, because if you change your relational database, you add a column, you give it a default value, and you add it to your DTO, and you're happy because it's there. But it's not there. So what do you do? We want them to work. So we did one of the kinds of tests I hate the most, but, had to do something. People don't really believe you when they said, I've learned my lesson, this won't happen again, because they know me. So what we do is that when we change an event, or the structure of the events, we write them directly to the database, in our tests, that is. So every time we change something, we add one of these more in our fixtures. So then every release, we test for every version we've ever had of every event, and we're happy. And it turns out it's good that people don't trust me, because it has caught a lot of things. So we also learned that you can't trust me. Everyone except me already know that, apparently, but that's okay. So another thing is, hopefully, if you're emitting events somewhere, on a queue, on a Kafka, I don't know, a log somewhere, REST endpoint, you can have them anywhere you want. You probably have someone that is using them. So it's a new kind of users. It's your fellow developers. They're easy to talk to, and the customers though, but they're still really angry if you break stuff for them. Probably more angry than customers, because they know where you are. And that's not good. So we had to figure out how to solve this. And we tried two different ways, well, many different ways, but two actually worked. There's a test strategy called Pact. I don't know if anyone has heard of it. But it's developed by real estate company somewhere in Australia, maybe. And the idea is that when a producer of something runs its tests, it records everything, just like you do with in Ruby, for example, when you use recorded tests, whatever they're called, VCR. But they also upload them somewhere, so to a broker. And then when a consumer wants to run its test, it will download them and replay them and see, oh, can I handle them still? And if that works, you're probably happy. So there are several teams using that at Klarna. My team is special, so we launch all the services instead, which takes a lot of time sometimes. But we want to be cool, so we want to use Docker and Kubernetes and everything cool you can imagine, because that makes it more secure, I've heard. So we launch the entire applications. And we do different verifications on them. After we run our tests, we also see that, oh, is everyone downstream happy? And if they are, fine. If they're not, we'll go talk to them and see why they have a problem, because, we don't make mistakes. But something good in testing is that since you're now not directly talking to anyone, hopefully, you should have very low coupling and have less synchronous neighbors. Normally a problem when you have microservices is that if you want to test one, it calls two different services, so you have to spin those up. and then they call two different services. You have to spin those up, and then you spin up the entire system. And that's not that fun. And then you end up with staging environments and other horrific things. So hopefully you can get rid of that and instead use, for example, Pact or something similar. And just replay the events. See that you can still handle them. And all you need is yourself and the thing you use as a message bus. For us, it's Kafka, which I can tell you stories about, but I won't. So, monitoring is an important thing, and we were really good at it, we thought. I mean, it's kind of normal to think you're good at something. We monitored, memory, disk space, number of 500s, number of requests. If a neighbor goes down, we know that, so the on-call people don't call us, they call them instead. And if for some reason an instance goes down, that's fine. Everything was fine. If something went wrong, we knew about it. That was a fact. But now you have events, and you have consumers, and you want to know that the consumers have handled all the events that have been created. So now we're looking for something that didn't happen. That's hard. So how do you know that something that should have happened didn't happen? If we emit an event saying order shipped, and someone should send out an invoice on that, how do we know that they did? How do we know that we didn't miss one? This is our setup, a little bit simplified. We have an order service, emits events to Kafka, and we have a consumer doing something useful. So we Googled and thought, okay, we're not the first one with this problem. Someone has solved this for us. And we Googled and couldn't find anything. And that makes me first wonder, what am I doing wrong? Because definitely the entire world didn't understand something I didn't. Something is wrong with me. But I couldn't find anything, and I thought, this sounds like fun. So we started developing something instead. It's really a warning sign, but we still did, because it's cool and all that. And we invented something called breadcrumbs. So we didn't invent breadcrumbs, but we have kids. We read Hansel and Gretel, and we saw that sounds like a good idea. Except we want to count the breadcrumbs. We don't want to find our way home. We want to see that they're all there. Sounds a little boring in real life, but so now we add more Kafka. In general, when you have problems with Kafka, you can add more Kafka. Well, you have more problems. Yeah. So now when we create something in the order service, in addition to what we did before, we also send something to another topic we call breadcrumbs. Yeah, really clever. And then we added a service here called breadcrumb monitoring. And that one now sees that, okay, so I have a create for this, and I expect this consumer to send out an invoice. But I don't have an event saying I sent an invoice yet, so I'm probably in alert mode right now, given that it has passed 10 minutes, of course, because otherwise there would be a lot of alerts. But then when the consumer finally does its job, it emits another event saying, I sent the invoice. And everyone is happy. And this also has the side effect of knowing that if, God forbid, we have an incident and something goes wrong, we can now know that we have handled all the problems, which is really nice. And then, about a month ago, someone came to me and said, have you looked at this Riemann thing? And I'm really sorry, it's not a bird, but he's not a bird, so I don't know. I could have photoshopped one in, I guess, but oh well. So Riemann, it goes through the roof in coolness factor because it's event-based. It's made in Clojure, and it's like the most hip thing right now. So you really want to look at it. It's kind of hard to use because it's Clojure, but don't tell anyone because, you know, you want to learn Clojure. It's an amazing language. No, really it is. And this is event-based, and you can do everything we do with events, with our breadcrumbs monitoring with it. So if I were me today, well, if I know this, then I wouldn't have built it, but now I did, so now I have it. But you don't have to. Use Readman instead. And it can also listen to Kafka, or you can use HTTP or whatever to create the events. Our checkout team uses this to monitor if the checkout on a web page has started loading, they also verify that it finished loading. So they know, I don't know, if there are a problem with JavaScript or something. I don't really know that world that much. Something unexpected. I'm really jumping between things here, but deal with it. So you're now submitting messages and people are listening to them. Then they can get a weird sense that you're a message bus and they can send messages through you. And that's not really true, but let's have a look at an example. Now we have a really complex setup. So we have our order set service, that's me, and we have a Kafka, and then we have 3 different consumers down there. And we have a checkout service that's creating the order. So when a checkout is complete, they generate an order. That's how the world works. And one of the consumers, they have a really important requirement. They need to know how many birds the customer have, because we're going to make important statistics on this. We're going to make us a lot of money, and that's valid. I mean, we can't say no to that. So they go to the checkout service and say, do you know how many birds you have? And say, yeah, sure. And then they talk to each other and say, okay, so how do we communicate? Well, you create the orders and we listen to them. So of course, you just add it to the order. Unfortunately, that's me in that team. And I don't want to know how many birds the customer have. That's not the part of the order domain to me. I understand that they want it, but I don't want to give it to them. And in the first maybe 6 months, because this happens a lot, in the first 6 months I just said no. I didn't make many friends. So when people start when we started meetings and people started saying, so what would Mikael say no to today? I get the vibe I had to change something. So I got the brilliant idea on my team, because I'm not alone actually, I have friends. We actually do mob programming and stuff, so I really have friends. But anyway, we decided, so let's solve the problems for them instead. So the next time someone came with this, we said, you can't send this through this service, but we'll build a new service for you, or we'll figure out another way for you to do this. So instead of becoming a problem, we became the solution for them. The result of that being that we have a lot of services now that we don't really involve in our domain, but it's still better than increasing our order object or whatever your world is to become bigger and bigger and bigger. Because if you remember in the beginning, I said that a really good point is that you can have queries and you can tailor them to your needs. And if you have everything in your one big thing, kind of lose that point. So it's important to be nice, apparently. Protect your domain. This bird is very cute when it's fat. Domain objects are not. They're never pretty, actually. So don't let your domain become fat. Try to stay away, but be nice. The same thing is true for when you're on the other side, when you're consuming the events. Because just because you're consuming someone else's events doesn't mean you don't need state. And if the events aren't perfect for you, then that's your problem, not the ones emitting them. The events they are emitting is what happened in their world, not what happens in your. And you're probably friends and all, but keep boundaries. So let's see an example here with send invoice when an order has been shipped again. So the order service, order sent, please send an invoice. The send out service can now solve this in many different ways because they have a problem, and that is that this event doesn't contain the address so they don't know where to send it. And now they don't want a database because, it's hard and stuff, and they don't want to decrease their SLA and whatnot. So they think, okay, but it's okay, we can go to the order state and fetch the order. Then we don't have a database. But where are they fetching it from? Is it some magical wonderland where you don't need databases? No, they have a database. It's not their database, but they still have the same SLA effects that if that database is a problem, then they have a problem. So maybe that's not that great anyway. And also they probably get the data in the wrong format or whatever, so they need to do extra work. So then they think, okay, but can you just not include like this thing I need in the event? Because I don't want state. Can you just include the address to where to send the invoice? I mean, it makes sense. And I can agree, it makes sense, but when you have had the same request 100 times, you would have very big events, and everyone would hate you for having too big events. They kind of already do. So, no. Store it yourself. You can listen to all the events. A database is not dangerous. They are pretty reliable, So be nice. Now we're jumping again. When we started out long ago, like 2 years, we discussed using an event schema because we heard that good. And we looked at, for example, Avro and Protobuf, which are two different. There are many different event schemas. But the problem we had was that the arguments people had for using an event schema is that now you can send it in binary and you will get a performance increase. And I have this thing, I don't really like that argument. So when someone says you'll get a performance increase, I'll ask, but I don't have a problem. And then I really refuse to use it just for being me. But what I should have said is that it will be easier for the consumers. It will be much easier to consume events when you can generate classes, if that's your thing. And just also it handles migrations and things pretty good. And it's also kind of hard to add as an afterthought. So if you're going to start using event sourcing or sending events somewhere on Kafka or wherever, look into, for example, Avro. It's worth the time. In our new services now, we use Avro, and it's been pretty good. We also get the performance increase. Yeah. This is how an event schema looks. If you can see it, it's just JSON. It's really fun. Eventual consistency, or not being able to read your own writes. My God, it's hard things. So you will have it. It's a fact. And I talk to a lot of product people, and I say that with some kind of weird despite that I don't really mean. And they say, so for example, in our app, when they read the order, it can't be not up to date. Because, I mean, they need the latest version. What if they pay and someone else have already paid or something? What if they have out-of-date data? Well, the thing is, when you read something in an app, it's not like you're like looking in the database. It did transfer on the wire, and probably took like 2 seconds for your brain to understand that it's there. So you already have the eventual consistent data. It's actually for writes that it's important. You don't want to do the same thing twice. You don't want to operate on things that you think are true when they're not. But there are tools for that. And if we're lucky, it's on this next slide. And it was. So, idempotency keys, which says, I'm doing this with this ID. If you have already seen this ID, just return the result of the last request with the same one. And e-tags, which is like the least heard thing of the web, but it's everywhere. You can do things like, if the order has the amount of 100, then do this. Otherwise, give me an exception. People have already thought about this. And that makes me feel good, because that makes me think that I may be on to something, because someone else have had the idea before me and they're smarter than me. 10 minutes, see? This, I think, is pretty fun, because I like weird problems. And it turns out that some events and messages are faster than others. I don't think there are birds with skateboards in Kafka, but sometimes I wonder. So, we have an example, and the arrows are in a different way. Still pretty simple. The order service is creating an order in the database. And when that's done, it's sending it to Kafka. And someone is really fast, and they're now updating the order immediately. It's the bluebird, turning the order blue. But the thread that is sending the create to Kafka has network issues, because network does that, and sometimes things just take longer time. And of course, the update doesn't have that problem. And now in your Kafka, you have an update before your create. And this happened to us. And people was not happy. Because we had promised them that they will get the order in the events in order. It's kind of annoying to have orders in order. But you know, network and stuff can cause things to change order over the wire. And we just, like, what do we do? The network is there. We can't have transactions over two different data sources. That seems hard. Well, we can have a lock somewhere else, but that seems harder. So we in our case, we added another service. So we have two services talking to the same database. I'm really sorry, but we do. And now when the order service creates the order, it goes in the database, and this new service keeps polling that database and says, give me everything that happened since this time. Or if you're really lucky, and in Amazon, you can use DynamoDB, and it has it built in. It has a stream. It's amazing. But I'm working at a bank, so well. Now everything is in order, all the way. Everyone is happy. And if I did have more time, you would see code, but now you don't. It's not really that interesting. We have our events in order. See, the birds, the best part of this presentation, I know it. There were good things. Our queries are always really, really fast, because they're always operating on the only index we have, which is account ID or order ID. And I think all databases can handle that. We use Postgres a lot, and there's no problem. And it turns out that sometimes people come up with the idea that maybe we shouldn't just be in one data center since we're a bank. Usually after something went wrong in that data center, because you know. And then they say, please be sure you have your data in multiple places and that you can always be available everywhere. But it can't take too much time, because you know it's no business value. But it turns out replicating immutable data is really, really easy. All we have to do is the same thing as we did when sending it to Kafka, but to another database. We just pull it and store it. No updates, so that's good. And you can't query the data easily. In my previous jobs, statistics people, or well, you know, for good reasons, they've come to me and asked, can you run this one-off query? It's not worth doing, you know, for real, because it's just going to be one time. And then you spend like 4 hours. And then the next week they come, you know that thing last week, can you do it again? No, because you said it, didn't save it. Maybe I should blame myself for not trusting them. But you can't actually do that. It's great. You can just say, no, I can't. Because I can only get one order. You can have it here if you want to. So you have to build the things that you actually need. And that makes me happy, at least. So you can send it to Elasticsearch or the data statistics thing they use. I don't know what they use. And you encourage good domain models, and that's really important to me because DDD is awesome and everyone should use it always. And nothing is ever deleted. Greg Young, one of the big people that talks about event sourcing and CQRS, he's amazing in all ways. And I remember one quote from one of his talks, like he starts with, and he says, "Did you get a C-level approval for deleting your data when you're using CRUD?" Because they never actually told you could delete anything, could they? And it's like the most valuable thing you have at your company is the data. And you're just deleting that all the time with your updates. Probably not a good idea. Audit log and history is free, as long as you actually have who did things in your events or when it happened and things like that. You get that for free. I remember, I don't know, a year ago, a product came with the requirement that you need to show the history of orders. How long will it take? And it took 2 hours. It was really great. Made everyone happy, especially me. And, the code is on GitHub. So, was it actually worth it? For us, it was. But I'm not the kind of guy that says, this was amazing for me, so now you have to do it. It was great for me. I don't know, try. It comes with a lot of cost, but so does everything, right? One thing you have to be aware of is that you will have to create a lot of services. And that comes with a cost as well, unless you're really good at it. So my team and teams around it, they maybe are of 4 or 5 people, and we have 30 plus services, which is a lot. Then you can't spend 2 weeks every time you want to create a service. So yeah, you have to optimize that as well. And it's not just technical. Your organization kind of has to be on board with this, because you're emitting events, and probably you need to teach other teams how to consume them instead of reading from an API that they already knew how to do. And then you have to convince people that why it's good. And then you have to talk about eventual consistency and learn to say no, which you already should. Should be the default response to every question, no. Pretty pictures, if you want. But that's it from me. The code is on my GitHub. If you can't read it, you probably can't. But it's okay. If you have any questions, feel free to find me, email me, tweet me, whatever. It was fun to be here. Thank you very much.